Hi everyone, it's Ben here, and today I'm going to be looking at quantitative chemistry for GCSE Chemistry. We'll just be taking a look at the mole mass mol relationship, a bit on stoichiometry and percentage yield, and a couple examples. This is meant to provide some foundation knowledge for your maths and chemistry skills. In order to really perfect this, the only real way to do it is with chemistry questions on practice papers. But we do go through a few examples here, so I hope they help. So we'll just get straight into it. So the mole is the unit for an amount of substance in chemistry, and 1 mole of a substance will contain 6.02 times 10 to the 23 particles. That number there is known as Avogadros constant. So given that information, if we were asked to find how many particles within 2 mole of a substance, we could just do 2 times 6.02 times 10 to the 23. Chuck that on your calculator to get 1.204 times 10 to the 24. So quite a simple calculation, and something like that could give you 2 marks potentially. So moving on from there, the molar mass is the mass of 1 mole of a substance, and it can be found by adding up the varying atomic masses from the periodic table. MR is a little just shortened version of molar mass, just for reference. So if we were asked to find the MR, the molar mass of carbon, we just look at the periodic table, we can see the 12, so that would just be 12. The units for molar mass are grams per mole. Going down from there, what is the molar mass of oxygen? Again, look at the number, it's 16. They won't ask these sort of questions, it's just to build some knowledge on calculating your molar mass. The exact same will apply for your compounds. So in order to figure this one out, you just go 12, which is the molar mass of carbon, plus 16 times 2, as there are clearly 2 oxygens, in order to get 44 grams per mole. So here we have a little relationship triangle. So you've got mass on the top, MR and mole on the bottom, which clearly shows that mass is found by doing MR times mole, and mole can be found by doing mass of MR. So with that in mind, a little example question. How much CO2 is produced if 10 grams of calcium carbonate, which is CaCO3, decomposes? So CaCO3 will decompose to CaO plus CO2. So what I've done here is, for the sake of learning, I've put a little 1 in front of CO2 and CaCO3. And what this is, it's known as a stoichiometry ratio. So for every 1 mole of calcium carbonate, there is also 1 mole of carbon dioxide. And this is important because in order to calculate the resultant mass of carbon dioxide, we need to know the MR and also the mole. So just starting off, we've got 10 grams of calcium carbonate, and our MR can be found by just adding up the MR of the elements within the compound. Add those up, 100 grams per mole. So then we can just find our mole by doing mass of MR. So we'll do 10 over 100, which is 0.1 mole. Moving over to CO2, we found on a previous question that's 44 grams per mole for carbon dioxide. And the mole, because there's this 1-to-1 ratio, mole-wise, between calcium carbonate and carbon dioxide, the mole of CO2 is also 0.1 mole. So then mass, we can just do 0.1 times 44 to get 4.4 grams. So from 10 grams of calcium carbonate, 4.4 grams of carbon dioxide are produced. Moving on from there, we're going to be looking at percentage yield, which is just a measurement of how much of your product you actually create compared to what's expected. And there can be numerous reasons for this, such as the temperature of your reaction vessel. So if it's not at the sufficient temperature, the reaction may not complete, which means you don't get the desired amount of product created. The time is about 100. So this is the formula here. Actual yield times theoretical yield times 100. The 100 will just turn into a percentage. So a little example. If a reaction should produce 50 grams of product, but only gives 40 grams, what's the percentage yield? So the actual yield is 40 grams, as suggested, and 50 grams is the theoretical yield. Another way to remember this is, you can't have a percentage yield that is over 100%, because that is impossible. It just makes no sense. So obviously, in this case, 40 grams is our actual yield. We'll divide that by 50 times it by 100 to get 80% percentage yield. So that is our percentage yield for a given reaction. They wouldn't usually hand it to you like that. It would be specific to, you know, a certain reaction and that sort of thing. But that's the basics of it. And we'll go over more detailed questions in a future video. So yeah, that's the very basics of quantitative chemistry. I hope that helped. Drop me a comment if you have any issues with any questions or anything I've gone over. Definitely the key with this is just practice. Practice will make perfect, and you'll do just fine if you practice. So yeah, I'll see you guys in the next one. Thank you for watching.